Hi all, welcome to part 4 module 5 computer networks. So before starting let me tell you one thing, please finish the part 3 because it's purely continuation of part 3 only. So without completing part 3 you can't follow this. Yeah. So hope you gone through part 3. So now welcome to part 4. So what we discussed so far is about the ARP protocol, and the role of ARP is the conversion from the IP address to MAC address. So till that is clear for you. Now the thing is that how this process will be done by this ARP utility. So one thing is like the domain name system routine or something. What you can do is you can keep a configuration file, something like a configuration file, right, where you will keep the mapping like so for 192 dot the dot is creating the problem. Yeah, 192.32 dot right 65.5 corresponds to E2. Similarly, say another address 192.32.63.8, say this one corresponds to E6. So like that you can create a configuration file kind of thing in every machine, and at least this machine could hold the configuration file containing information about everyone inside this particular network. So this is one way, but typically how many machines can be there as part of a LAN, or what about the changes that are happening? If something happens to the network interface card, definitely it is this E2 is going to be changed, it will be replaced with something else, so that value has to be replaced here. And similarly, if IP address itself may change, right, when the say particularly mobile host and all, if you are moving to a different network, of course this will be changed and a new Ethernet address is to be given. So like that the updations is a problem. So whenever such updations were there, you are supposed to update it in the every machine, right, because everybody is keeping this kind of a configuration file, or maybe in a common server you can everyone can ask him for this mapping, right. So that kind of a difficulty is there, and we don't have to go for that much difficulty. Instead we can handle this problem in a simple way. So what we can do is we can just use something called a broadcasting, right. So whenever this E1 want to have a communication with this host 2, it needs this E2, right. So that is its target. Somehow it want to find this E2. So what it will do is it will create a special packet called an ARP packet, ARP request packet, and inside that ARP request packet, requesting for the corresponding MAC address, it will there will be many information, and we will see the structure of an ARP request packet soon. So inside this ARP request packet, what it will do, it will so particularly it will mention many things were there, more things we will see. So minimum it will ask like 3265.5. I just want the corresponding MAC address of this IP address. So that is something how the ARP request will contain. And not only this, it will contain its own mapping, like that many things will be there, but minimum what it will ask is, so this is the ultimate aim of this ARP packet. So given this IP, what is the corresponding MAC address, right. So it will be asking, and it will do it will broadcast this particular packet. So this will be broadcasted means everybody will receive it, right. So here it shows only host 1, host 2, the 4 hosts were highlighted, say 3 and 4. Let me call, there is another host called host 5, there is another host called host 6. So like that many hosts will be connected to this particular Ethernet switch and also to this, and now everyone will get this particular ARP request packet which is broadcasted, and all will see whether this is my IP, right. So host 5 will check its IP address with this, no match. Host 6 will check its IP address with this, no match, right. This host 1 sent actually, so other than host 1 everyone else will check. Now when host 2 is doing that checking, yes, there is a hit. So someone is asking my IP MAC address, right. So like that the host 2 will understand immediately. Host 2 will reply back with its MAC address, that is E2. Now the question is whether host 2 will reply this back directly. I mean how this host 2 will reply this E2 to host 1. So for replying back, host 2 will understand what is the IP address as well as MAC address. MAC address is needed. This E1 is needed. MAC address of this particular machine, then only it can do this communication. IP is also needed if it is in a different network, and that we will see, right? And something like this. So those information will also be there in the ARP request. So ARP request packet, we will see inside ARP request packet. First it will introduce itself, right? I am host 1, I have an MAC address E1, I have an IP address this one, and I want to know the IP address of this one. So like that the ARP request packet is generated and it is being broadcasted. So by looking at the ARP request packet, the host 2 will clearly understand the MAC address that is of the one who asked this. So it will do. So whenever this is broadcasted, it is correctly reached this host 2, and host 2 will do what? Host 2 will unicast the reply, right? So that is very important. The ARP request packet is unicasted, but ARP reply is unicasted. Unicast back to the one who asked for it. Who asked for it actually? This H1, host 1, right? So actually host 1 generated this ARP request, and that is broadcasted, and host 2 identifies that yes, this IP matches with me, and to this broadcast message host 2 will give a ARP reply which is correctly unicasted to host 1, because in the ARP request packet the MAC address of the host 1 is available. So that is the reason. If it is not available, again it has to do another ARP broadcast to get it. Like that it will be more confusing. So to avoid that further, make sure that whenever that ARP request packet is coming, ensure that who is generating that ARP request, its MAC address, IP address, those information should be kept inside the ARP request, so that whoever is getting that ARP request and whose IP address is matching with the IP address in the ARP request, he can unicast the reply back to the correct sender, right? Hope everything is clear. So that is being shown here. So this first row, the second and third row we will see. So that is about communication from a host on one network to a host on a different network, that we will see later. So host 1 is trying to communicate with the host 2 on the CS network, the first network. And if you see these, these are all the information that are having as part of this ARP request. So the source IP1 will be mentioned in the ARP request, and the source Ethernet will be Ethernet address E1 will be mentioned, and it will correctly deliver to the destination, and destination IP is IP2, and for delivery it is broadcasting is done, right? And the destination Ethernet is address is found to be E2. So far things were clear, right? So for that particular host 1 to host 2 communication. So just a single level, and initially a broadcasting of the ARP request followed by a unicasting of the ARP reply, and the actual as soon as it is getting that E2, now this host 1 can do unicasting of the actual data it want to communicate with the host 2. So everything extra, this ARP, DNS, these things are actually overhead, but still we want it for making our communication possible, right? Otherwise it's almost impossible. So let's see the points we gone through. So let us start out by seeing how the user on. So just I am explaining only. So those things I explained already with the diagram, and just going through. Host 1 sends a packet to host 2 on the CS network. So let us assume that the domain name is like eagle.cs.uni.age. The first step is the IP address is to be get by host 1. The host 2 IP address should be obtained. It's for that it will do something called a DNS lookup, and DNS lookup is something we will see in detail on the 6th module. For the time being, this will give you the IP address correspond to a host name. So the DNS returned the IP address to be of 65.5. Hope you remember. So the upper layer software on host 1 now builds a packet with this in the destination address field and give it to the IP address. Alright, here there is something worth noting down. So the IP software can look at the address and see that the destination is on the same CS network. This is something I missed explaining you. So this is again something very nice concept. So with the help of the host 1 want to communicate something to host 2. Hope you are with me, you are with my speed and all. So go slowly and understand the concept, that is important. So when this host 1 asked given this ask this domain name system, it return it something like 192.32.65.5, this IP address. So before doing that broadcasting and all, first this host 1 should understand that both me and my destination, right? My IP address is 192.32.65.7 and I want to send something to a destination with IP address 192.32.265.5. Whether we both are on the same network or not. If we both are on the same network, I can go for the ARP broadcast and things will be doing as I explained so far. But if the destination is on a different network like host 4, it should be something different. It is to be handed over to the router and from router it should reach the destination. So that is the procedure. So how the host 1 will understand that that host 1 himself and the destination with IP address 192.32.65.5 are on the same network. So hope it is clear for you. Something I tried explaining this already in the IP addressing part. So that is for that we are actually depending this subnet mask /24. So what is this /24? /24 is actually so 24 ones, that is 255.255 is 888.255. So totally 8 plus 8 plus 8 plus 8, 24 ones dot 0. So what it will do is, given an IP address, when you perform this AND operation with the subnet mask, right? With the subnet mask, you have to perform the AND operation, right? What you will get is the starting address of the subnet. The subnet address will be get. And the bitwise AND operation is something you have to do. So all those things we already discussed in our fourth module. If you have any doubt, go there and understand. So just write everything in binary and do the bitwise AND operation. You can see that when you perform AND operation with ones, the other part will retain as it is. So it will be 192, this will be 32 and this will be 65, and when you perform AND operation with all zeros, whatever be the other part, that will be ANDed to, ANDed with 0, the result will be 0. So this is the subnet address of this particular IP, right? So this is about the IP2. Now similarly it will do the same process with its own IP. So like the IP1 192.32.65.7. so this one IP1, right? It will do it with the 255.255.255.0, right? So when it perform this AND operation, the result will be like as usual 192 will retain because all ones and this 32 will be retained, this 65 will be retained, again this 7 will be converged to 0 because of this AND operation. And this is about the IP2 and this is about IP1. So both IP1 and IP2 are giving you the network address to be 192.32.65.0, right? So you are getting the network address to be 192.32.65.0, 192.32.65.0. That is how you are understanding yourself that both the source and destination are on the same network. So I don't have to cross the router, of course. So some kind of broadcast I will get the MAC address, and once I get the MAC address I can do the further further communication of my packet with the help of the Ethernet switch, right? Hope it is clear. So this is a very it's a very important concept at this point, right? Yeah. So but similar thing we will see again when we discuss the communication from host 1 to host 4, and that time when you perform this this kind of a operation with that mask, you will understand that both of them are on the different network. So definitely you have to do what you have to cross a router and the procedure will be something different. So that is what we are discussing at this point. So as soon as the IP address is obtained, it will be handed over to the IP software, and IP software can look at the address and it will see that the destination is also on the same CS network, and the logic behind this is what I tried to explain so far, right? So however, it still needs some way to find the destination Ethernet address, right? So one solution is to have a common configuration file somewhere in the system that maps the IP address to Ethernet, the first solution we discussed. So while this solution is certainly possible for organization with thousands of machines, of course, keeping all these files up to date is going to be error prone and time consuming. So if you have something different, that will work fine. So the better solution is for the host 1 to output a broadcast packet onto the Ethernet asking who owns the IP address 192.32.65.5. So once it sends that broadcast, everyone will get it, right? So broadcast will arrive at every machine in the CS network, and each one will check its IP address. So only the host 2 will understand that it is its own IP. So host 1 alone will respond with its Ethernet address because it understands that it is my IP, so it will respond back. That is unicasting, right? So in this way, the host 1 learns that the IP address is on the host with the Ethernet address E2. So as soon as it is getting it, it can have the normal communications. The protocol used for asking this question and getting the reply, that ARP request, ARP reply, so that protocol. So this is where we introduce the protocol, that is the address resolution protocol, and it is defined in the technical documentation of internet standard, that is RFC, request for comments 286. So you can see more details about it under that RFC. So almost every machine on the internet runs it because they are request reply. It should be run as a background process in every machine as part of the operating states available. The advantage of using ARP over configuration file is, of course, its simplicity. You don't have to go for an erroneous time consuming configuration file management. It's just simple. Some small overhead will be added just before starting the communication. The system manager does not have to do much except assign each machine an IP address and decide about the subnet mask. That's all. So MAC address is already there with the network interface card. They are getting the MAC address, and IP address is assigned and subnet mask is assigned. Rest of the things will be taken care by the ARP. At this point, the IP software on host 1 builds an Ethernet frame address to E2, of course, and puts the IP packet inside it as the payload and dump it to the Ethernet. So the Ethernet network interface card can now understand that E2, right? So it will detect that it is my frame and recognizes it as a frame for itself and scoop it up and causes an interrupt to the process. Back. So the Ethernet driver extracts the IP address, IP packet from the payload. So the IP packet is now wrapped inside the Ethernet frame. From the Ethernet frame, the actual IP packet is unwrapped and taken and passes it to the IP software. So which sees correctly that it is addressed to it, because in the IP software will look at the IP address and it will verify that it is exactly for me. So that is the working. So hope the working is clear. Now let's see something about the optimization part. The various optimizations are possible to make ARP work more efficiently, right? Every time you will be thinking whether we have to broadcast every time or not. Why don't we have some optimization? Of course, you can have some optimization, like you can cache it. I mean, that mapping information you can cache. To start with, one machine can run ARP. It caches the result in case it needs to contact the same machine shortly, right? So if the same if it is want to communicate with the host 2 again and again, no need to broadcast again and again. Simply by keeping a cache, from that cache it will get the mapping second time and it will send it directly. So next time it will find the mapping in its own cache, and thus eliminating the overhead of sending second broadcast. In many cases, host 2 will need to send back a reply, forcing it to run ARP. So this is something I explained in between, because in that ARP request itself, that mapping should be correctly conveyed. Otherwise, what will happen, the other one to give the reply back, again it is forced to run ARP. So that should not be the case. So for that, this ARP broadcast can be, the second level can be avoided by having host 1 include its IP to Ethernet mapping in the ARP packet itself. So when the ARP broadcast arrives at host 2 with a pair like 192.32.65.7 E1, that is the sender's the one who is sending the ARP request, right? The host 1's IP address and MAC address. So that is entered into host 2's ARP cache also. And in addition to that, on the way, as it is broadcast, everyone else will be hearing this ARP request, right? So everyone will get this packet. So all machine on the internet can also enter this into their mapping. So if they also want to communicate something into host 2, they can do it with the help of the cache. So it's very nice, right? Things going smoothly so far. But what about the changes, right? Because if you keep on caching the things in between, some change happen, you may be having a wrong communications. To avoid that, to allow this mapping to change, for example, a host is configured to use a new IP for if, maybe because maybe if, there are different reasons why you have to change the IP. Sometimes you may be moving to a different network, or sometimes that IP address pooling and all, we saw somewhere, like with some limited dynamically the IP addresses were given, maybe with some 1000 IP, the internet service provider may be managing some 3000 users, so every time they may be dynamically allocating which is available free. So in that case and all, IP may vary, so that time how this cache data you will keep up to date. So the entries in the ARP cache should be timed out after some time, otherwise you may be getting the wrong old data again. So that is the thing. So a clever way to help keep the cached information current, that is up to date, and to optimize the performance, of course, something intelligently proposed, and the solution is like every machine broadcasts its mapping when it is configured. So when it is configured, in the sense whenever the IP address is changed, a new configuration will be there for the machine, right? So whenever the machine is configured with a new IP address or some change in its address, what it can do is it can just send an ARP broadcast. Actually, it is not for a purpose, just to inform others that the information changed, that's all. So it is sending an ARP broadcast without expecting any reply, of course, for informing the configuration update, right? So the IP, whenever there is some update to the IP address, it will be informed to others by this way. It is look nice, but there is a problem in it. So this is how this broadcasting will be done. Who will be the destination? Destination will be the same machine itself. Actually, the intention is not for the ARP mapping, it is just for informing everyone about the new change, so that they should update their cache accordingly. For that purpose, whenever a machine undergoes some net IP address change, whenever it is configured newly with a new IP address, it will send this ARP broadcast to itself, something like that. So even though it is sending to itself, simply as it is broadcast now everywhere, it will be broadcasted, but the destination IP address will be kept as its own IP address, so that it will not match with anyone else, so that no one else will reply it back. So that is the idea we are using. But unfortunately, if someone else reply you, what will be the solution? Just like another one is saying that yes, this is my IP and this is my Ethernet, maybe a fake information, right? So what will happen is, already this IP address is owned by the sender. Now someone mistakenly saying that he is also owning the same IP. So every machine is now so to broadcast reply kind of thing from the broadcast ARP request on cache entry is updated, and from someone fakely saying that it is his IP, and he is communicating back with his MAC address, and that time with the same IP another entry will be updated. So like that it will create confusion, and it is something fully fake. And the whole concept is called gratuitous ARP, something like that they are given the name. Maybe something unexpected happened, so that is a word meaning when I looked into it. Anyway, I hope the addition is clear for you. But how to deal with this? If a response does unexpectedly arrive, two machines have been assigned the same IP address, and that will lead to some conflicts. So the error must be resolved by the network manager before both machines can use the network. So in such case, it should be informed to these, so that that cache to entry is getting with the same IP address. It can be triggered as an interrupt something to the network administrator, and the network manager can manually handle it. So that is a way for as a solution. But normally, unless everything is working fine, I mean, so if everyone is working fine, there will not be any such situation. But in maybe due to a fake machine or some malfunction, only this will happen, and that time it could be resolved by the network manager in some different way. Some kind of troubleshoot, anything can be executed, right? So that about it. So let's wind this part at this point. Further, we will discuss ARP on the next part also, because it has to be more clear for you, like how that communication is happening from a machine on one network with a machine on another network. So that is a general scenario, right? So with that, we will wind up the discussion on ARP and also something about the ARP packet format and all. Yeah, thanks for watching.